Welcome to the Crazy Hat Chemist. So another video here on, what is it? Kinetics. Hopefully we have a fast rate. Bam! So a kinetics calculation number 5. So suppose a starting concentration of 0.750 molar. What is the concentration in molarity at 15.6 seconds, knowing the rate constant is 0.0286 molar per second? So I want you to think about this here, and I want you to look at the rate constant units. So this is moles per liter per second. Okay, and knowing those units, you should know the order of the reaction. So since it is not just per unit time, it is not first order. Okay, this is actually a second order kinetics problem. Knowing that it's a second order kinetics problem, we're going to be using the second order rate law. And here is the second order rate law. That second order rate law is 1 over concentration of time minus 1 over concentration naught, which is the initial concentration, is equal to kT. So what do we have from this here? We have a starting concentration of 0.750. That's going to be going into x sub naught. We are solving for the concentration at a specific time, so we're going to be solving for x sub t. We know the amount of time, and that is 15.6 seconds. We know the rate constant, and that is 0.0286 molar per second. Notice that the rate constant and the units of time in terms of time is going to cancel out, and so we're good there, and so that's a fantastic thing. So let's plug in those values into that second order rate law, and that's what we get right there. You should see that the seconds in terms of time are going to cancel out with the rate constant and the total time, and we are going to solve for 1 over x sub t, which is the concentration at time t. So we're going to do a little bit of multiplication. We're going to do some rearranging. We don't have a natural log here, so this is just a simple solve for x problem, although even it makes it a little bit more difficult that x is in the denominator, but not so bad. So I've gotten rid of the fraction here. I've took the reciprocal of that with the 1 over 0.750, and I've done that little multiplication of the rate constant and the time, and that's right there. I've gotten rid of my units because I do know that I am solving for molarity, so those are the units that have not canceled out thus far, so I'm okay with that. I'm going to move that negative 1.33 to the other side with an addition problem, and that's what I have. 1 over concentration of, or 1 over x sub t is equal to 1.78. I'm going to solve for x sub t, and that is taking the reciprocal of this number here, and I'm going to stick some units on there because I do know that it's molarity. So x sub t, or the concentration at time t, which is 15.6 seconds, is 0.562 molar. Now I want you to think about this problem and look at the initial concentration. The initial concentration is 0.750 molar. So at a certain amount of time, no matter what that time is, you should have less concentration at that time than you had initially. So the initial concentration at 0.750 is like having 100%. So at a certain amount of time, in this case 15.6 seconds, you're going to have less than 0.750. And so that number of 0.562 should make sense to you. So you always need to be thinking about the numbers of which you're getting. Don't just blindly do the math and then go, well, that number is just fine. Think about where that number is in relation to what you are solving for. All right, so that was another Crazy Hat video. I got a crazy hat for you, and this is one of my favorite ones here. Okay? Oh yeah, I love this hat. Okay, give me a thumbs up if you like that video. Subscribe to my YouTube channel. Pass my YouTube channel on to all your cool chemistry friends. Maybe pass it on to your parents, your grandparents, your aunts, your uncles, your younger brother, younger sister. Maybe your cat can even subscribe to my YouTube channel. Maybe, just maybe. Maybe your dog or your parakeet or your pet gerbil. Who knows? I'll see you next time for more Kinetics problems. Bye for now.